Metasploit is a common suite that collects exploits, and you just take the exploit and you run it. It uses Ruby and uses a specific client hello. So when you connect via TLS, some firewall detected that is the hello that usually comes from Metasploit, and the firewall is going to drop it, regardless what you send. And so with Go, it's quite easy if you write your own reverse proxy to just take whatever comes from Metasploit, rewrite some headers, rewrite the client hello, because you can do that, specify the ciphers that you do, so you can clone perfectly the Chrome handshake, and the firewall is going to let you through. And that is one kind of proxy that you do to yourself to make the tools behave, which Go is great at.
I mean, I must say, that's scary, dude.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean's developer cloud makes it simple to launch in the cloud and scale up as you grow. They have an intuitive control panel, predictable pricing, team accounts, worldwide availability with a 99.99 uptime SLA, and 24/7, 365 world-class support to back that up. DigitalOcean makes it easy to deploy, scale, store, secure, and monitor your cloud environments. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Put on your dark hoodie, turn off all the lights, and join Tom Steele, the author of Black Hat Go, as we explore the darker side of Go. And make sure you listen to the end. We've got a 30% discount code. Okay, here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about Black Hat Go. We're going to teach you how to steal billions of dollars while ensuring that your code remains simple, clear, and maintainable. Joining me today, Johnny Borsico. Hello, Johnny.
Hello there.
How's it going?
It's going quite well. I'm actually feeling pretty peppy. You might have heard about there's this virtual Go conference going on in a few weeks. I think you might have something to do with it, like maybe you're emceeing or something like that, right? So I'll probably be making an appearance and giving a keynote or something.
Awesome. That's gogetcommunity.com, right?
That is correct.
On May the 21st.
Yes, sir.
Okay, great. Well, are you excited to learn about hacking in that?
Oh, boy, am I.
Yeah, me too. I feel like, this is going to be quite an episode. Don't worry, though, we don't have to do it alone, as usual. I'd like to welcome back Roberto Clapis. Roberto is an ex-security consultant and penetration tester, now a chocolate factory boffin at Google. Hello, Roberto.
Hello, hello. Thanks for correctly pronouncing my job title, my actual job title. That's good.
Security engineer at Google. Is the
yes,
that's the boring version.
No, but that's the who cares?
But what was that? The register called you a chocolate factory boffin, didn't they?
Yes. We found some things in Safari, and they weren't happy about that, and they decided to make a funny blog post about it.
Okay, well, we'll have to put that in the show notes, and you can tell us more about it as well later. Because I need to welcome our final guest today. It's Tom Steele. Tom's one of the authors of the book Black Hat Go, and a research consulting directory at Artridis Partners. Did I say that right, Tom?
Yeah, you got it good enough. Yeah.
Close enough.
That works.
Welcome to the show.
Thank you. Thanks for having me. Excited to talk about all manner of things, I guess, so far.
Yeah, well, let's find out what we're going to talk about. It's exciting. Well, first of all, it's nice to kick off to get to know each other a little bit with any working from home tips. We're all working from home a lot more these days. Has anyone got any tips?
The best tip that I can give you so far is to always have something to drink on your desk, and a lot. So you drink, you stay hydrated, and that after a while automatically reminds you to stand up and go somewhere else, like in another room in your house, so that you also keep the blood flowing.
That's quite a good little system.
You can always tell how much work I've been doing by the amount of cups on my desk. They just kind of accumulate over time, over the day.
You should garbage collect sometimes.
I'm excited to talk about the Black Hat Go book because it's not often you get a lot of technical books that have titles like, and this sounds a bit like I'm just doing clickbait, but one of the chapter 7 is going to blow your socks off. It's called database. Is it databases and file systems pilfering and abusing? I saw it twice. It's something like
abusing databases and file systems.
Okay, so chapter 7's called abusing databases and file systems. That is a great title for a chapter.
I don't know. I have the book right here. I can double check for you if you want.
Oh, yes, please.
The physical one.
I know, right? That tree.
I didn't know they did those. What have they done? Just printed out the internet? You should get Tom to sign it for you.
Yeah, definitely. Later, yeah.
I don't mean like with a signature. I mean like add up all the characters in it and send a checksum.
Oh,
no?
Boy. Okay. Yeah, okay.
There's something about that.
Where does it come from, Black Hat, the name? What does that actually mean?
I don't know. So, like, you could probably ask 100 different people and get 100 different answers. We kicked around a bunch of titles for the book when we were first coming in. And I personally wanted to stay away from Black Hat Go, like the name Black Hat. So I think our original title that like Chris and I came up with was Adversarial Go, which is probably more descriptive of what we actually do on a daily basis. Because like the term Black Hat, I wouldn't exactly describe what I do on a daily basis as Black Hat because, I'm obviously always doing it legally with, people know I'm doing these things, right? They're paying me to do them on a daily basis. I'm not doing them to illegally make money or anything like that, which is probably more what you would think of Black Hat. But the publisher wanted to sort of relate it to Black Hat Python, which was a Python book that came out a number of years ago. And I think they came out with the second edition. It's a really good Python book too. But there's also in that no starch ecosystem, it wasn't like a white hat book, but there's like gray hat C#, who one of my coworkers actually wrote. That's a really good one too. But that has a lot more like parsing out maybe like vulnerability management style stuff. Also has like SQL injection and those sorts of things. So I think more along the terms of like what No Starch was thinking was like these are more like attacking based tools versus what a defender would use. But typically with white hat, black hat, that historically has been more like criminal versus, authorized type of testing. However, we all go to like Black Hat, the conference every year, and most of us are not criminals anymore.
Plus, it probably boosts sales too, right? It would be, it was like it's not dull and boring. It's like it's more of you're going in the offensive. You're gonna poke holes in people's systems. That sounds way more fun to me.
Yeah, and I think so. Like the goal for the book, like when we got asked like who the audience was, the audience wasn't people that know Go already. And I don't even think it's people like that know Go from the Go community. Like certainly if they wanted to go pick the book up and like see something, like expose themselves to some things they might not be exposed to, that'd probably be a good choice too. But the audience was really like the people that I work with, in the security industry, or maybe people just getting started, or they want to learn a new language and then they want like useful tools that they can go apply. Because, if you pick up a programming book and it's just strictly, this is how you do X, right? Like this is how you handle arrays, or like this is how you do a for loop. That's great. But if you give yourself projects that you can like actively use in your work, those tend to help you learn the language quicker. And so that was really what we were going for. Yeah. So it just sort of spurred off of my history with Go, which was I started using Go, I think 7 or 8 years ago. It might be like the first commit like to GitHub, where we had a tool that was written in JavaScript using Node, and I basically used Go to rewrite that. And that was my first introduction. And after that, it sort of became the tool for everything. Obviously it doesn't handle everything that we need, but it handles most of the tasks. And I became very productive with it. So after an extended period of time, I felt like we could do a book like this. And my co-authors, Dan Coatman and Chris Patton, they're also amazing Go developers as well. And, the book wouldn't have came to a close without those guys. Certainly Dan pushed it to the end for us as well.
So if I may give sort of review of this book. Like I've been having fun with it, honestly. It has shown me different use cases, right, for Go, like that typically don't think about, right? I'm like, you can do that with Go, and you like, I now have a whole new appreciation for the net package, and I'm like, I'm blown away by some of the things you can do, and I've been having fun with it, extracting bits and pieces there in meetups and teaching people about, writing port scanners and building proxies and things. I mean, it's been incredibly fun to really like having these kinds of projects where you're not just learning syntax, right? You're not just learning the mechanics of Go, but you have things to build, and that kind of fun. I don't know. I've really been enjoying this book. So kudos to you and the others. This is a really great book. I'm having fun with it.
Awesome. Thank you. Yeah, I think that's probably like the most useful aspect of Go for us is the ability to just interface with TCP, and do it very quickly, and start doing interesting things like writing odd proxies. The amount of times that we've been trying to get out of a network, had to write some crazy proxy to get around things we've done a lot, done quite a bit. So yeah, it's awesome.
That has been basically my experience with Go. During a penetration test, we needed to build a weird proxy that needed to take a WebSocket on one side and needed to downgrade it to a TCP connection on the other side, because that's what we got. Because when you do penetration test, you get going whatever you get going. And so we needed to write a proxy, and I just started learning Go. And I said, well, one is a netcon, the other one is an IO read-write closer. I can just IO copy them together, and let's see if it works. And it works. And it was my first experience with Go in writing a tool that I actually needed at work. And it's a blast because you just use Go, stuff that is in the standard library. Actually, in your book, I think most of the imports, you don't even mention them, because just running Go import on your snippet would import all the right packages, because you just use a lot of standard library and some external packages here and there, which I really appreciate.
Yeah, you can get away with, like you said, you implement a reader, you implement a writer, and all of a sudden you've got a tunnel.
Yep.
And we've done that across various, you can do it all. You can do it at any layer. So if you want to do command and control over S3, and then write that back to WebSocket, it's pretty much just piping Legos together type of thing, right?
Yeah.
Yeah.
We used to use Python both for capture the flag competitions and at work, but at some point it would just become so complicated to handle the multiple connections and concurrency and all the threadings. Plus, you need Python to be installed on the system that you're attacking. When instead with Go, you can cross-compile to whatever weird baffling architecture you find, and you just push the executable, which was a big plus.
Yeah, for sure. I think that's probably the most welcome feature is, obviously lack of dependency. So, for the people that aren't familiar with this stuff. So a lot of the stuff that we do, we work together as a team, and the projects can range different type of things. But one of the things that we do a lot is we're trying to attack a company, right? So this is a bank or something like that. Let's just say hypothetically, and we're not necessarily testing a specific application. We do a lot of that stuff too, but we're trying to get into this company by any means necessary. And so once we gain code execution on, say, an end user's workstation, right, like a Windows PC, that's when the fun really begins, because you have to figure out how to get out of these networks that sometimes are locked down. And that's where Go becomes in handy quite a bit, is when you need something really quick and you need to compile it to Windows with no dependencies. That's great. It's a great feature, right? And so it's just been great. Or maybe you're working with a coworker and you have some little utility, and they want to run it. They need to run it right away, or you're moving fast. Sometimes having them install Python and then install the dependencies and handle all that can be a nightmare, because now you're not just saying, "Here's my tool, use it." You're basically, here's package management, or maybe they've never used whatever language you chose to write it in, right? I don't know. Ruby Gems seems to be the most historically awful one.
Yeah, I was about to say, how much time did you spend trying to make Gem work for your Metasploit?
Yeah.
That has been one of the worst experiences in my life. And yeah, Go doesn't betray in that sense, especially after a while. After a while, I started building a library that I just would use for scripting, because Go is also good for scripting. And in that library, I had the utility functions, like some of the tunnels that you explain in your book. I would never dream of building in some of the things that you wrote about. But I have these utility libraries, and you just pull it in and you call it, and it just gets you running in a short time. And it's also nice to see that it doesn't require that much, that big machines or beefy computers. It just runs on very low-end hardware. I once had to do a penetration test from a Raspberry Pi, and I was grateful that Go was low footprint.
Also, low compile times helps a lot too.
Yep.
I've been playing around with Rust. We won't get into that, but it's just
this is a Go podcast, mate.
yeah, for sure.
So I kept thinking when going through the book, and I'm still going through it, I've kind of been jumping around a little bit and learning about the different projects and whatnot. It kind of begs the question, like, how did you pick some of these projects? Because a lot of them are like really fun. So there's like credential harvesting, there's a key logging, there's like building proxies to get around corporate network. There's interacting with Metasploit over RPC. I mean, there's writing DNS tunneling. How do you pick those, to me, like really fun projects? Like, do you pick the projects and say, okay, well, what are we teaching here? Or do you say, okay, we need to teach these things? What kind of projects would sort of convey that what you're trying to teach?
Yeah. So I would say like the majority of the chapters came from thinking about how do we use Go during like our testing, and what kind of utilities have we written, and do we know a lot about, and like how is it useful for us? So pretty much every single thing in that book, we've used that. Like there might be something small that we've used. Now, the hard part was taking perhaps a bigger tool, a bigger project, and then paring that down to something that's like that you can actually digest in the book. And so, the stuff in the book is like really useful, but it's all basically getting you started on what can I do in addition to this. So, but everything in there is pretty much like we had used that first. Like there's something in there that we had used for a test. And then there's a few stuff that like, obviously some of the guys like they like have like a ton of expertise. Like Chris Patton wrote the steganography chapter, and like I am not the guy to talk about that, but like he has a long history with that sort of thing. But yeah, so and then basically like we built a huge list, and then we kind of pared it down to what we could actually fit in the book. There's some stuff that didn't make the cut quite because it would have been a little bit too much background, a little bit too much lab setup type of thing. Like some of the VoIP stuff that you can do. It's really awesome, but you can't really set up a virtual environment for some of that stuff, right?
Right.
But yeah, so I think that's kind of how we went about it. Like for example, like the DNS proxying, like we do that a lot. So that came from like we use a lot of tools to do what we call command and control, which is basically like we have a binary we have a payload, I should say, that's running on a system that we don't control. And that's communicating back with us. And you can do that over multiple protocols, but one of the great ones is DNS because it gets out of most networks and, those sort of things. But a lot of the tools that are used there, they don't necessarily handle like redundancy or proxying natively. Like you're basically client to server, that's it. But if you can use Go to write up a quick proxy that maybe fans those out, or at least gives you a layer in front of those, that was a great way to do it.
So when you talk about proxies then, is the purpose to intercept and sort of have a look at and kind of spy into the traffic? Or is it to control it or modify it in some way? Or does it sort of depend on what you're doing?
I think there's room for both with Go. I think there's been times when we've needed to, we're testing, say we're not doing like sort of like this adversarial type of testing of an entire company. Say we're like just testing some software and we need to get in front of the TLS stack and start doing interesting things there with inspection. Like Go is great at that because you can actually, like, it's so easy to copy the existing TLS package from the standard library and modify that and then use that in your own code. Like, that's really easy to do at Go. I'm sure it might be easy to do in other languages, but for me, it was easy to do in Go. Very simple. And so we've done that before where like maybe some clients implementing TLS in a really weird way, and we've had to do that. But for the most part, I think for my use case and the stuff that you'll see in the book, it's more like shaping traffic, like being able to get in and out of networks and around and move things. So think like, interesting style of reverse proxies.
Since you mentioned TLS, rewriting the TLS package, one thing that I wrote a proxy for was that Metasploit, when you use it, Metasploit is a common suite that collects exploits, and you just take the exploit and you run it. It uses Ruby and uses a specific client hello. So when you connect via TLS, some firewall detected that is the hello that usually comes from Metasploit and other things, and the firewall is going to drop it regardless what you send. And so with Go, it's quite easy if you write your own reverse proxy to just take whatever comes from Metasploit, rewrite some headers, rewrite the client hello because you can do that, specify the ciphers that you do. So you can clone perfectly the Chrome handshake, and the firewall is going to let you through. And that is one kind of proxy that you do to yourself to make the tools behave, which Go is great at.
Yeah.
I mean, I must say, that's scary, dude. Like, honestly, I mean, I knew we were going to, this was going to be a fun episode, but some of the things you can do, and I've seen sort of talked about in this book, and the stuff you're mentioning now is, like, you can do that stuff with Go. It really blows my mind away.
How much time does your team spend building and maintaining internal tooling? I'm talking about those behind-the-scenes apps, the ones no one else sees. The S3 uploader you built last year for the marketing team, that quick Firebase admin panel that lets you monitor key KPIs, maybe even the tool your data science team hacked together so they can provide custom ad spend analytics. Now, these are tools you need, so you build them, and that makes sense. But the question is, could you have built them in less time, with less effort, and less overhead and maintenance required? And the answer to that question is yes. That's where Retool comes in. Rohan Chopra, engineering director at DoorDash, has this to say about Retool. Quote, "The tools we've been able to quickly build with Retool have allowed us to empower and scale our local operators, all while reducing the dependency on engineering," end quote. Now, the internal tooling process at DoorDash was bogged down with manual data entry, missed handoffs, and long turnaround times. And after integrating Retool, DoorDash was able to cut the engineering time required to build tools by a factor of 10x and eliminate the error-prone manual processes that plague their workflows. They were able to empower back-end engineers who wouldn't otherwise be able to build front ends from scratch. And these engineers were able to build fully functional apps in Retool in hours, not days or weeks. Your next step is to try it free at retool.com/changelog. Again, retool.com/changelog.
So it makes me wonder then, is this book potentially arming people with information that they could use to do some harm with?
Probably.
And what's your ethical position on that, Tom?
So I'll put it this way. Oftentimes the best people that get into the hacking, but I'll just call it security industry, like the offensive security industry, the best people often come from development roles. Like one of our guys, Ryan Hansen, he lives in Idaho with me. And when I first met him, he was a developer working in Boise, but he has become one of the best security people that I know because he understood the software at a level that you just don't get by just only doing security, right? So all hacking is really just understanding the underlying mechanisms and then thinking about how you can subvert them. And so showing someone how to do SQL injection, for example, that would be more of a script kiddie type of thing, right? And you can go read about that stuff, but the best way to understand SQL injection is to go write your own SQL package. And that's a great way to handle it because now you know how to defend it and you know how to attack it. I don't have any qualms about ethically teaching.
Yeah, there is one more ethical standpoint, which is if you put a book out there, the attackers and the defenders have the same amount of knowledge, right? If instead this knowledge is just shared across attackers, maybe the defenders, which usually are software engineers, don't get access to this. So they might not know about this stuff. And I found that putting information out there is usually good for defense, even if it is aggressive or black hat or adversarial knowledge.
Yeah, it sounds like that answer is legally watertight, Roberto. Have you actually had a lawyer check over that sentence? Because I think you've nailed it.
Well, so like one of the things that we deal with a lot is bypassing antivirus or EDR controls, right? So you have something running on your system that's supposed to prevent code execution and payloads from escaping and all these things. I don't actually have a problem teaching people how to bypass those things, because if we bypass them, it's a game of cat and mouse. Like, those companies will improve their detections, and they'll actually come up with detections that maybe work, or they won't advertise detections that don't work or are easily bypassed, right? Because it's one thing to say like, oh, well, you could say like, we have this machine learning algorithm that blocks all this stuff, and it's like, well, not really, not really. It turns out if I just name my binary World of Warcraft.exe, like, it just kind of works, right? Those sorts of things.
People just immediately click it. Yeah.
Yeah. Like, I think, the ability to identify and bypass these controls just makes the defenses stronger. And that's how we evolve.
Yeah. That defense could be used to excuse any crime as well. But yes, I take you.
So true. I have broken into physical banks before, and yeah, that's fun stuff too. But you should always get approval prior to attacking a network or physical location.
Yeah, I was waiting for that bit after you said that you broke into banks.
Yeah, you don't want to do this stuff. You don't want to do this stuff. You don't want to be doing this stuff unauthorized. Set up virtual labs and that sort of thing. That's definitely the way to go. I wouldn't say go attack random websites, but like, there are programs like HackerOne and Bugcrowd and stuff like that where you can go, get approval to test those sorts of things, even if you don't have experience.
We'll bleep out the names of those pieces of software. Although this book, apparently, you can just use the book.
Oh no! Well, those are sites like where anyone can go like sign up to do like security testing of websites.
Gotcha.
They facilitate.
Yeah, and those are collectors of programs, bounty programs, in which you go there and you see which companies will pay you to do the tests on their systems. You attack their systems, and if you find a bug, you get paid for it. It's not usually that high of pay, but it's nice when companies put it out there.
So is it fair to say that the things that do make it into the book, such as this one, are the things that are at this point well known, right? Is there new ground being broken? And I'm going to go and assume like yes to some degree, but please do elaborate. Is there new ground being broken and I don't want to say black hat, but or is it like a mix? Is it like a remix of different exploits to get to new things?
There's no sort of 0 days in this book. They're all well-known techniques. And I did want to put something in there that I was advised not to.
That's so cool.
It was how to bypass like a certain product, and they're basically like, you can't do that. Okay, cool. We won't.
We should ask our folks at Changelog how airtight our show legal stances.
We didn't send Tom the link for this Zoom. So there's your answer.
So the book talks about things in generalities, right? And yeah, they're known techniques, they're known flaws. And I think again, if you're on the defense side, if you're doing software development, knowing the attacks is definitely better than not knowing them. For example, you want to know how to do SQL injection so that when you're writing your application, you don't develop with that. And you always want, I think if you're writing software, you always want to sort of be like, well, what could happen if someone does this? I think those are really good questions to ask, right?
Yeah, that might be why you say that developers make good security engineers, because when it's your job to kind of defend against it and you realize how hard it is, maybe you just think, you know what, I'm just going to go on the other side of this because it's, I don't know if that's in any way kind of helps that. But
yeah, so long time ago, another company I worked for, we were trying to basically bring up a bunch of people up to speed on web application security. And the typical way you do that is you basically just build a vulnerable web app and then you teach them all the offensive techniques that you can. But I actually took it the other way, where I made them build a web app and then implement the defenses, because I felt that was the best way to get an in-depth knowledge of how to identify and then possibly like bypass those defenses, right?
It does.
And that works. What I really love is when you teach security knowledge to software engineers, and you see that a software engineer that maybe didn't have a certain concept just start clicking into it, and it goes like, Because once I was out at dinner with a friend of mine who is a extremely good software engineer, and I was talking about cross-site request forgery, which is one kind of vulnerability, and after a while he was like, I have to go. And just walked out. He was like, four people, and he walked out and he deployed a fix, and he was like, thanks for that. I didn't know about that.
Yeah.
That was the best reaction.
Well, okay, so I'm seeing a lot of parallel with sort of operations, like in my line of work, and I do SRE currently. So I've found that developers and engineers, they tend to think of sort of the operability of something like towards when they start needing to like ship it, right? It's like a concern, like I'll worry about that when I get to it, right? And then we sit down. I'm like, well, have you thought about this? Have you thought about that, right? Before putting this thing into production, they're like, oh yeah, let me go back and fix it. So it's almost like security, right? And like, making sure that your software isn't vulnerable to some obvious things. It sounds like this is also one of those things where, as an engineer, you focus on building features, and then you go sit down with the security review team, and they start poking holes in your thing, and you're like, now I got to go back and plug those holes, right? So is there like the art of engineering requires so much more than just writing features, right? And I'm seeing this parallel in this talk.
Yeah, I agree. I think that you obviously want to try to design your feature with security in mind from the beginning. However, I am very sympathetic to that, to like basically to having to just get something running. Like that's another flaw that you see a lot in the security industry too, is the exact opposite, where they come in and they basically go, this has no security, but they're not thinking about the fact that it works or it needs to work first. You know what I mean? And so like there's a lot that goes into building and just making a product run that sometimes you need to be able to give up a little bit of security as well while you're getting that going. So I think there's a happy medium, and that medium is constantly moving depending on basically like your risk.
Yeah, I wrote an application once and I did something wrong and basically couldn't sign in. It was the most secure application I think I've
That's
created.
Exactly.
So secure it's unusable.
But it just didn't work at all. Yeah, so it was just a bit too secure, and that was how I was pitching it. If anything, we've made it a bit too secure. So, yeah, I think it does.
Well-designed APIs are made in a way so that using them in a secure way is easier and less effort than using them in a wrong way. And that's usually what a library designer tries to do, because otherwise people are going to go for the easy road because they have to deploy.
Yeah, but they of course have to know what those things are. And that's where I think a book like this comes into play. Is Go good as a kind of foundation for writing secure code? Is it, because I've heard different things said on this subject. How does Go stack up when it comes to security?
Yeah, I think again, like you'll probably get a bunch of different opinions on this. My particular opinion is I think it does a lot of things correct. And I think the way people that are probably using it, I think it's probably a good thing to grab. The fact that you have to be pretty explicit about things helps quite a bit. So, the compiler will help you with a lot of bugs, right? And then, yeah, I think, the fact that it's statically typed, and yeah, it just makes you be explicit. You have to explicitly handle lots of different things, right? Like perhaps, I'm not going to get into this, but the lack of generics probably helps, right? In some of those things, and it makes the code a little bit easier to trace and that sort of thing.
Shots fired.
But yeah, and I think the Go standard library, like I think it does most things correctly as well. So for example, like code execution, like remote code, like calling like command exec. The fact that there isn't a version of that where you can just provide like a string with the arguments, basically, right? Like that's a secure design in and of itself.
Yeah, and also if you look at the SQL package and the HTML package, like the SQL package makes you use prepared statements or parameterized queries.
You have to try very hard to write. You have to basically pass it format strings or something like that. Yeah, you have to. You have to know what you're doing. Yeah, to screw it up there.
See, that is cool then.
The HTML template does contextual auto-escaping.
Yes.
I think Go was one of the first languages in the open source world that had it. Maybe there was a Java library by Google, but
if you go check out the documentation for that library, you'll basically see a reference to a paper about contextual aware encoding, and then no one. Basically, I don't think any other language read that paper and implemented it, because I'll talk about it. I'll talk about it with when I'm doing software assessments. I'm like, well, you should do contextual aware encoding. And they're like, what's that mean? We do HTML. And I'm like, okay.
Yeah.
So for anyone not
You know-
familiar, this is where when the template's rendered, it knows if it's putting it inside, say, an attribute
Yeah.
versus in the body
Right.
as HTML to be seen, and things like that. So it
Right.
it does different things depending on the context.
Yeah, and interesting things can happen if you HTML encode data into like a URL parameter type of thing, right? Or JavaScript.
Yeah, I maintain the package, and every time I have to send a CL to fix some things, I always shiver a bit because it's so precise and so well done, and has to have no bugs, because any bug there can become a vulnerability that is so disquieting to add code to that. Also, the paper that you were talking about, Tom, I think is like several tens of pages of schemes and very hard to read text. So
It's not easy.
yeah, it's not for everyone.
Well, the Go team read that kind of stuff for breakfast, don't they? So that's what I like, because it is solved for us, and as developers, we get to just use it.
Right.
But so thinking about that, then are there any common gotchas? And actually, this was a question I got from Kamal on Twitter. He asks, what are the most common mistakes that developers make that lead to exploits and security vulnerabilities?
Yeah, so I thought about this. So at Tretis, we've actually tested quite a number of Go applications. So like, we do a lot of software security type of things. And so the things that I see, and I was going to go into that, this is actually a nice feature of Go. Like, for example, like say you want to take JSON and you want to move that into a struct that you eventually want to insert into a database, right? This is like a very common thing, right? The nice thing about Go is that you are explicitly defining the fields that you want in that struct, right? So you're not going to get random fields. Like, for example, if you were using something like Node, we see this a lot, where they basically take request.body, if you're familiar with that, and they slam it into a database, and now you've got real problems in your hands. So what I see is that actually works quite well, right? Because now you know the object that you want, and then object in quotes, right? And now you've also defined the field types. You know that what's coming in is going to be a string. Sometimes it might, cast energy to a string depending on, the library that you're using and that sort of thing, right? But you are defining at least the data types that you want coming in. So the stuff that I see from that, just from that end, is sometimes you have a struct that represents, something that's in the database, like a user item, right? If you serialize that directly into the database, directly from JSON, you've got something called mass assignment, right? Where you're basically not filtering the fields that you expect, because your form might take 3 fields, right, that define the user. Maybe let's say the first name, the last name, and the email address, right? However, what if you have another field that's like a Boolean, is admin or something like this, right? Just because your form doesn't provide that value doesn't mean that the user won't provide that. And when you serialize that JSON or that form value even into the struct, and then you put that struct in the database, you've got a serious problem on your hands now, right? Because now they're starting to modify objects and things like this. So we see that quite a bit. SQL injection, we don't see that a lot. Cross-site scripting, don't see that unless, we've seen some really nasty bugs when people are writing their own templating engines. I've seen some particularly nasty ones.
Oh.
One actually resulted in code execution. Yeah, so this particular instance was basically they had a partial template that would load the user input from a database, right? And then that partial template would then get rendered into a parent template. And because they took that value as trusted, that you could put code in there, right? And so you had like this double eval type of situation. But I think those are few and far between. I think most of the Go things that we're testing, people aren't actually using templates to render server side anymore. They're mostly using like JSON or other services. However, I would probably stick to the standard Go template, or at least something that wraps that pretty thinly. That's just my opinion. But we don't see a lot of that stuff. So we see that mass assignment issue. For whatever reason, like cross-site request forgery, we see the protections implemented, but like often incorrectly.
Yeah, if I might add, I also saw that a lot because people don't have it in the standard library. It's in X, CSRF token. So people don't see it, people don't know about it. And so far, I've found that to be one of the most common vulnerabilities in Go applications.
What should you do?
Be careful. Yeah, go ahead.
Basically, whenever you take a request that is state changing for your server, so that afterwards your server will do something different. For example, if you take a search query, it's probably not state changing, but if you get submission of like a subscription or some user data, you might find that to be state changing. You need to use the XSRF token package to protect your form. Basically, there needs to be an extra parameter that you strip away, but it needs to be there and needs to be tied to the user and to the session. Otherwise, attackers can craft those requests. I will link the package in the podcast.
Yeah, and my advice there is, the CSRF packages themselves are actually good. It's when you try to get clever. So my suggestion is be explicit with if you're building an HTTP application, build a handler that accepts only a post request. Don't process a head and a get and a post in the same handler, because that's when you're going to end up with some lot. What I've seen is they protected the post verb with CSRF, but they will process a head with the same value, right? So that can be a big issue as well.
I'm just going to go.
No, I haven't done that. Fix some things.
So CSRF, some CSRF bypass stuff is one. We see a lot of they want to implement CORS headers, right? And I've seen some really interesting bypasses there where you're not using the correct regex, but a lot of that stuff has been resolved.
Yeah, okay, but to be fair, CORS is hard.
No, it's difficult. Yeah, it's difficult.
Was not made to be understood by humans. CORS was a big mistake. Shouldn't have been there in the first place.
Yeah, every time I have to go explain one of these bugs, I go reread the Mozilla documentation so I don't say anything stupid.
I do the same.
I think we already got Roberto's unpopular opinion.
On the idea of being explicit, if you are building your API to only take in JSON, don't accept anything else other than JSON.
Right.
There's no reason to sit there and parse text plain or URL form encoded input if you are only wanting to use JSON. And I haven't seen a lot of that in the Go web frameworks where they require that level of explicitity. I've written something that I can link later that does this on a per handler basis, which I think is the way to do it. I actually stole a lot of these ideas from the author of Happy.js, which they do. If you want to go look at a framework that implements a lot of things well, go look at that framework. Happy.js, Iran Hammer has done an excellent job with that. But yeah, validate all your inputs too. Don't just depend on the struct mapping. If you're accepting an email address, make sure that's an email address. I'm not super happy with the way the validator libraries in Go work. There is one that's pretty good. At least it gives you good definitions, but then you have to go write your own wrappers and things like that, which I don't know. That might be just the story of Go web development in general though, right? Is you got to implement a bunch of stuff yourself.
Yeah.
One of the things that I hated the most is the content type. In Go, if you don't set any content type in your responses, it will still work. Probably. Because the Go server tries to guess based on the response content what is the content type and will set it on the response for you, which means that if an attacker can somehow make the server respond with something that looks like HTML but is instead JSON, the server will set an HTML content type, even if your endpoint only returns JSON. So as Tom was saying, you should only accept JSON if you expect JSON. Same thing the other way around. If you want to return JSON, set the content type.
Yeah. Being explicit is definitely helpful.
Okay, so when you say that, there's something that immediately comes up to mind, and that's the fact that most developers, basically, there's always this bias towards, easy to get started, easy to get going, just grab this thing, drop it in your code, and, if you run into any issues, go to Stack Overflow, copy, paste whatever you find, and go, right? You get the job done, right? There's all this sort of emphasis on easy, and not enough on, do you know actually what it is that you're putting in your code base right now, right? So the frameworks, they tend to hide and make things easy. And, I remember back when I was doing Rails work, there were articles about how Rails basically prevents you from shooting yourself in the foot from a security standpoint, right? You can't get a little Bobby Tables kind of situation in your system if you're using Rails, right? Because you're hoping that the framework is going to take care of these things for you, right? But at the same time, when I think about it, I'm like, shouldn't I know as a developer, why that something is working, right? Or said it is working, right? In order to be explicit about, which is the advice we're giving here, in order to be explicit right? That means you kind of have to dive deeper. You kind of have to go lower, right? You basically leave the abstractions of the framework basically behind, get deeper in order to know exactly what's going on, right? There must be some sort of happy medium there. I'm not sure where it is in this context, the context of this conversation, but is your advice to sort of default to the explicitness versus relying on packages and frameworks?
Personally, I think that if a framework is well designed, like for example, Rails gives you a hand in Ruby. If a framework is well designed or a package is well designed, like the HTML template package, you should not know. Like you should be able to use it and not have vulnerabilities. That's how a framework should be done. But then if you want to do an extra step, for example, in the HTML template package, there are some types that tell you these might cause a security issue. It's written in the type. If you use this type, you're exposing yourself to a risk. That's the time when you need to go back and reread the entire thing and understand the threat model, understand how those features combine and everything else. Because at that point, you're on your own.
I definitely think that like there's things that you shouldn't implement yourself. And I definitely think you should rely on, packages, if you can, that you trust and are from from trusted sources. I think, but you got to remember, if you import something, you're now responsible for it. And so, with Go, we've seen some interesting things where like some packages were overriding the user agent header and HTTP clients and things like this. And like, you don't know that it's doing that, or they're opening files in the background and you don't even look because you're just like, well, this is the thing that I wanted to do. Right. But I don't think you should implement everything yourself. When I meant like be explicit, I meant more be explicit in what you accept as valid input from an unknown source. Don't trust the input coming in, and interrogate it as much as reasonable before processing it. Yeah. So yeah, like in relation to that, like we see good encryption, like good use of encryption. Like no one's writing their own version of AES, but then I also see like people using it incorrectly. So the difficult thing with Go is people aren't writing. Typically, if they're leveraging Go, they're doing something probably pretty interesting, pretty difficult as far as like they're breaking new ground in their application, because this isn't just like, oh, I can just use WordPress and write a little plugin that does it, right? Like they're breaking new ground, they're doing something tough, and so you might have to use encryption there. And so yeah, I do see quite a bit of like basically using encryption without validation, yeah, stuff like this. Don't really see hashing used incorrectly for whatever reason. Like people seem to be pretty good at that. And then I guess like the individual flaw that you won't see in other languages for the most part is like unbound concurrency is huge. And so what I mean by that is like, I'm going to put this in terms of HTTP just because it's the easiest one for me to like relate to. But like you have an HTTP handler and you accept an array, and then you launch a Go routine for every item in that array and process that. We've seen that quite a bit, and that always leads to
trouble.
Because I think, yeah, the request limit on Go is like 10 meg, right? So you can imagine an array of 10 meg. You can generate quite a bit of Go routines that way.
Mm-hmm.
Hi there, this is John Calhoun, one of your GoTime panelists. When I'm not working on GoTime, I create programming courses that help developers level up their Go skills. And one of my more recent courses, Algorithms with Go, is live, and I wanted to invite you to check it out. So it's completely free, and in it we explore how algorithms and data structures work, as well as how to actually implement them in Go code. So if you've ever had an interest in learning about algorithms or data structures, or if you felt like you understand them conceptually but just couldn't nail down that coding part, this course is going to be great for you. We actually dive into coding everything, we work on practice problems, and it's a lot of fun. You can sign up completely free at algorithmswithgo.com/GoTime. Again, that's algorithmswithgo.com/GoTime. And don't forget that last /GoTime bit. It helps me keep track of how you found out about the course so that GoTime gets credit for referring you. Thanks for listening.
funny because you think of this stuff often as like hacking and it's all low level. If you believe the movies, of course, it's like 3D cubes that have to fit together. When it all lines up and lights up, you know you've hacked in somehow.
And you need a wine too. Yeah.
Yeah. Yeah, you sort of think of it as being a very alien process, but when you talk about that, that's a very everyday thing. I'm sure most of our listeners will have dealt with JSON coming into some endpoint and done exactly the kind of things that you're talking about. So it's interesting that it's worth thinking just the very practical ways of abusing something, as well as things that are down at the TCP layers that you might not be exposed to too often.
Yeah, I mean, I think things that you get when you get down to like the TCP layer, if you're talking about like, the sort of like in the movies type of thing, or like these are relevant items like, such as buffer overflows and memory corruption vulnerabilities. You just don't have those in Go. Of course, you would want to audit and be careful when you're calling C libraries from Go, right? Or if you're using unsafe, it's called unsafe for a reason, right? If you're taking in like input from an untrusted resource and then passing that to a C library that you're wrapping, that could be disastrous. Don't see a lot of that though. Just for whatever reason, like we don't see whole lot of the need for people to wrap C libraries. And I think that's because Go makes it so easy to work with.
CGO is terrible.
Yeah, CGO is pretty terrible. I wasn't going to say it.
What's that? It's more secure.
It's not too bad. I use it quite a bit, but it's not too bad, but it's definitely not easy. But yeah, I just don't see a lot of that. I think most people, if they find themselves reaching for a C library, they're just rewriting the bits and pieces that they need and processing those byte arrays and stuff by themselves, which is good to see.
Yeah, and one thing that I also like is that people are using the race detector when they test their code, which is so Go is memory safe, which is great. But one thing that some people don't know is that it is memory safe until a race condition happens. If you have race conditions in Go, you might get memory corruption and remote code execution.
Oh.
So build your code with race.
Could that be abused, or is it going to just be random?
So it can be abused. Actually, in Google, we host a CTF every year. And one of the challenges of the finals of last year was to exploit a Go server by using a race. So you could exploit a race on the server and get remote code execution by just abusing this race.
Wow.
So it's doable. People did it. I think 6 teams solved it. So yeah, use race detector.
And what about fuzzing? I feel like fuzzing is also going to be really useful when it comes to this.
Fuzzing is going to be really useful, and also I think that the most voted proposal, or the second or third most voted proposal on the Go public repo is about fuzzing. So I would love to see it in the standard library, because fuzzing also makes it very easy to spot easy bugs and panics. I mean, like a denial of service is usually a bad bug. It's not a memory corruption, it's not an RCE, but you don't want your server to go down. And the fuzzer will try to feed complicated and input to your APIs, so you will find the DOS.
Yeah, that was going to be my unpopular opinion, was that denial of service is worse than you think. It's more critical than people think it is.
Well, we'll get on to that. Before we do, though, Tom, I just wanted to ask one last question. What's your mother's maiden name? No, okay, good. Now you've passed the test.
Date of birth.
Nearly. No, it's passed. It's too quick. It's too good. It is good. It's actually time, speaking of unpopular opinions, it's time for our regular slot, Unpopular Opinions.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
So, Tom, you were saying your unpopular opinion.
So my unpopular opinion is that denial of service is a big deal.
Oh.
And that's because if you build this awesome service and no one can use it, you're probably going to lose quite a bit of money if it's profit generating. And sometimes that can impact companies more than, say, like code execution can.
Yeah, of course. Yeah, I think that's a fair one. I mean, do people think denial of service is just not something to worry about?
Yes.
Yeah, most of the time. Most of the time, people's eyes glaze over when I start showing them bugs in their code with that. But.
Or they assume it's going to be handled, at the edge of the network or something by the provider or something.
One of my worst moments, I was presenting a vulnerability to the client, and I showed that with a single packet, I could make the backend generate several tens of thousands of packets and take it down. And they said, well, it only goes down.
Comes right back up?
Yes. Well, why did you build this? If it is fine if it goes down, why is it up anyways? Turn it off.
I thought they were going to say, don't send that bit. Don't send that byte.
Well, why would anyone do that?
Yeah, no one's going to do that. Tell us some other things that people say that's infuriating when it comes to security. Because honestly, it's good to hear, and it's actually quite useful for people to learn.
So I don't know. I think I'm blessed at Atretus. The customers we work with, they actually get it, and I don't get too much pushback anymore. I think we're evolving, and that's a really nice thing to see. Is I think we're evolving to where security and software development, they aren't as adversarial as they used to be. I think we all sort of want the same goals, and I think at least for the most part, the developers I work with and talk to a lot, they really do care, and they want to fix things, and they do take things seriously. But yeah, so I don't really see much of this. Well, why would anyone do that type of thing anymore?
So it doesn't take much convincing then to tell people, hey, because that code you wrote this way, you have a problem. You don't have to prove to them that they have a problem.
Sometimes. That's another debate too. Is we call it illustrating impact. But if you describing a problem versus having an actual proof of concept will be better.
I'm going to borrow that. Illustrative impact.
Illustrating impact.
Nice.
Yes.
Nice.
I've had different experiences, probably at different clients, because the most common questions that I got was, yeah, and then what? And you just prove that you can run arbitrary code on the server, and the answer is, yeah, but then what? And you're like, no, that's it. It doesn't go further than this.
Is that not bad enough?
Yeah, exactly. It's but what else do you want? It makes you coffee, but it's made with milk. What do you want from me?
Yeah, I'm looking forward to. I'm going to get the book. I'm really looking forward to number 7, the abusing databases one. I don't know if I'm going to be able to learn anything. I've spent lots of years abusing databases. I've screamed blue murder to Postgres, for example.
Yeah, I'm working with the publisher of getting a discount code for everybody too. So.
Oh, that would be sweet. If we pull that off, we'll put it in the show notes for everyone. Nice one.
Isn't it the other way around, that the database abused you in that case?
Yeah, actually, it's a good point. That's
yeah,
why
it's a database's fault.
Yeah. But what sorts of things? Obviously, SQL injection and stuff like that is kind of well known, I think. But are there other things that you have to look out for?
So I think look out for as far as regarding databases and security.
Yeah, are there any common gotchas around databases that people
don't store your encryption keys alongside your cipher's text?
Nice.
And do not expose that to the internet. Those are 2 steps you don't have to make, especially together.
Don't just do everything as root. Use permissions. Use the least amount of privileges you need. Don't store your encryption keys in the database. Yeah. Also, sign the ciphertext that you store in the database too. Don't assume that just because it's in the database, it hasn't been tainted with.
That's a good point.
Yeah.
Yeah. Well, another tip I like to do is I always have a field called password that I just put fake stuff in and just don't use it. So if anyone ever does look in the database,
it's like a honeypot.
Yeah. Don't encrypt passwords. Hash them. Don't use a secret key to encrypt the passwords.
Yeah. I always get worried when a web service, if I've forgotten my password and then they just email me my password, they must have been storing it in some way that they can.
There's a great, it's also great when you dump a database and then you see 500 of the hashes of the password is the same thing.
Ooh.
So then you know they got a default password, right? So
monkey. Yeah. That's great.
Matt, you should put nice try in the password column instead of random stuff.
I feel like that's just going to make the attackers angry, though.
Yeah, that's an invitation.
I'll give you guys a good security bug that you probably want to go. That everyone probably wants to go check their code out for.
Oh yes,
and that's when you're going to email it. So maybe you guys can answer. So when you're going to email a password reset email to a user, how do you get the domain name that you're going to email it to or from the link from?
Ooh, so I assume you don't just get it from the email. Andreas?
So you're taking in, like, let's say the password reset. So you're going to take in a user's email address, and then you're going to generate a link to your domain for your application with a reset token. And let's say you're securely generating the token. Everything's good there. How do you decide how to generate the URL?
That's some sort of configuration in your application, right?
Yeah, for sure.
Maybe you pull that from database or from some sort of YAML file. You that gets pulled and then at runtime you read it and then boom.
Yeah, that's the correct way.
Oh, I nailed it.
What we see a lot is people using the host header.
Ooh, bad move.
That way it works in test, dev, and prod, right?
Yep.
What?
I see.
Oh.
And what's the problem with that?
That the attacker can control the host header, and then it generates a link to their own domain. So the user clicks them.
Hey Matt, what's the host name to your new app you're working on? I'd like to try out some of these things from the book.
Yeah, I'm not going to.
The book mostly focuses on, like, once you've got access to a database, what do you do?
Pilfer.
Yeah, you pilfer. You pilfer. Yeah, that's right. You find the goods. You find the ciphertext, and you find the banking data, things like that.
Yeah. It's good stuff, isn't it, that data?
All that data.
This is it. Any final thoughts, anyone? We're approaching the end, but we've got a bit of time.
I have an unpopular opinion.
Well, another one? Roberto,
let's have
fire.
yours.
Go would benefit from enums.
Mm-hmm.
That's it. No, I want enums.
Okay.
Right. So you want to be able to specify a type where there's only a set number of allowed values, compiler checked.
And I want the switch to be exhaustive, because in many Go applications I found a way to bypass security by just specifying, 4 in an enum that only expected 3 values. So you end up in the default, and the default does other things. So enums would be a big security benefit, in my opinion. But that's my opinion.
It's a good one. Yeah. I don't know if I'd
Yeah, that's not unpopular. Yeah, I think that's fair. Yeah.
Yeah, because you can do them, can't you? With you create a type and then use the IOTA to
right.
const block. So it's possible to do, but you don't. It's not the same, is it?
Yeah, and then you parse form, you take the integer, you convert it, and where's your type gone?
Right. So you want proper enum support.
Yep.
Proper enums. Yeah, no, fair enough. That's a good one. That could be popular or unpopular. I don't know. I'm afraid we just don't know. But we'll find out for you, Roberto, and let you know, shall we?
Thanks. Put it in the links.
Yeah, we'll put it in the links. Okay, well, I think that's all the time we have today. Thank you so much to our guests, Roberto Clapis and Tom Steele. And Tom's book is available. Roberto, are you selling anything?
No.
Okay, Roberto's not selling anything, so that's fine. But seriously, Tom, where can we get your book if we're interested?
I think the best is No Starch Press.
Cool.
Yeah. Or it's on Amazon too, if you want to go that.
And there will be a link in the show notes.
nostarch.com/blackhatgo.
And I'll be getting, I should be getting a discount code for everyone for the ebook at least.
Well, that would be great. Yeah. So if we can pull that off,
nice.
That would be awesome, Tom. Thank you so much. Well, that's all the time we have today. Thanks for listening. We'll see you next week.
Roberto drilled that URL. It's nostarch.com/blackhatgo. Use the code GOTIME for 30% off. That's all caps GOTIME, and it should work for you through May 15th. Thanks to Tom and our friends at No Starch for hooking our listeners up. If you liked this episode and you end up reading the book, holler at us and Tom on Twitter. He's @_Tom Steele, and we're @GoTimeFM. This episode was hosted by Matt Ryer with help from Johnny Borsico and Roberto Clapis. It was produced by Jared Santo, that's me, and we get all of our music from the mysterious Breakmaster Cylinder. We are brought to you by amazing people at companies who get it. Thanks again to Fastly, Linode, and Rollbar for their continued support. Did you know we have a master feed? We do. It's your one-stop shop for all Changelog podcasts. You get the Changelog, you get Brain Science, you get Practical. Hey, you also get JS Party. I hear it's pretty awesome. Check us out at changelog.com/master or just search Changelog Master in your favorite podcast app. You'll find it. That's all for now. We'll talk to you again next week. I went back and watched that. Never Ending Story. Doesn't hold up, guys. Doesn't hold up at all.
What do you mean? Which bit?
I haven't seen it in a
The
very
movie.
long time.
The movie.
I thought it was airtight.
The graphics, you mean?
The movie doesn't hold up.
I thought it was logically sound.
I think the main issue is that it ends.
Yeah.
You never wanted
Yeah,
to.
you liked it that much?
It's false advertising, right?
Yeah.
No, it's fake. Yeah.
Fake news.
Yeah.
It's clickbait, isn't it?
My issue is it didn't end fast enough.
Right.
Giant flying dog. What kind of nonsense is that?
Yeah, it's a love dragon, but
Matt's personally offended at this point.
yeah.
He's like, come on, guys.
It's my childhood.
I mean, it was awesome during my childhood. I was excited to go with my kids. And so I'm like, come on, kids, this is going to be amazing. And then I sat there and I was like, what is going on?
Well,
right
yeah,
now?
but you can't compare to like the Avengers stuff. You have to show them.
No. Yeah.
Wait,
not
if
at
you
all.
have kids, you have to show it them in real time as you experienced it. You have to like rate limit. We could just do an episode on the Never-Ending Story, but gonna need a bit more
man.
time. Yeah, someone, Dylan on Slacks just said that Artex drowning in the swamp was the saddest moment in movie history.
In movie history?
It's almost as sad as when the Terminator slowly goes down into that lava.
With the
its
thumbs
thumb
up.
Yeah.
The thumbs up
I
is
mean-
hopeful, you know.
Yeah, but it gets you, doesn't it? Because you think, oh, it's really sad that Terminator's dead. That machine sent from the future to murder people. I feel really bad now that he's dead. So, it works.